Hello, this is INE Foundation Lab 2, Section 4.7, IGP Redistribution. Okay, before I conclude this section, let me explain some important topic, and I will come back and conclude this section. Okay, when we do show IP route on our favorite route, this command will show some parameters. One is non-wire, the other one is redistributing wire, and advertiser bar. Non-wire shows which root code or current or native router uses in this database. Okay, we can see our root code for show IP route. These are our root code. This is local, connected, static, RIP, and so on. The other one is redistributing wire and advertiser bar. We see these two items together when we have redistributed on that router. The redistributing wire shows in which routing protocol that route exists. Sometimes it shows in which routing protocols the route is redistributed, but it is not apparent in local router. It is apparent in other router in our network, not current router. Advertiser bar shows in which routing protocol the route is redistributed, or how is redistributed, or or by which route map it is redistributed. And advertiser. It is advertiser bar happens. It shows it happened in our local router. It is local to our router. The difference between advertiser bar and redistributing wire. On R9, let me to show IP route. If I do one, this is 39.9. This is non-wire. 39.9. Let it see our topology. 39.9 is this interface connected to R9. This is non-wire connected. If I do show IP route connected, it's the same as this command. Okay, we don't see redistributing wire and advertiser bar because we don't have redistributing on our router. Let me check this other route. IP route. Let me this one. Show IP route. Let me 3. Okay, this is our 35. This interface tape. The non-wire RIP. If I do show IP route RIP, we will see it in our RIP database. This is our RIP database. 35. Yeah. And we have redistributing wire, and we don't have advertiser bar because it is not distributed in our current router. And this is redistributing via RIP. It means we have this network in our RIP databases. Show run pipe section. So the RIP. We have in our RIP. We have it in our R3. Pipe section We have this step in our RIP databases. Okay, this was the show root commands. The other one is our OSPF metric type. We have two types of OSPF metric type. One is OSPF metric type 1. The other one is OSPF metric type 2. Type 1 root has a metric that is the sum of internal OSPF cost and the external distributed cost. So it's sum of internal OSPF cost and external distributed cost. It increases our cost, OSPF type 1. But OSPF type 2, the type 2 root has a metric equal only to redistributed cost. If roots are redistributed into OSPF as type 2, then every router in OSPF domain, the OSPF domain will see the same cost to reach the external networks. This is our difference between metric type 1 and metric type 2. Metric type 1 will increase our cost, but type 2 only it is our redistributed cost. Okay, the other one is this connected redistribution concept. Okay, when an explicit connected redistribution of a specific interface, this is what is explicit. This is we have done. This is explicit on our 3 on our 9. This is I have created root map and matched our loop back into root map. This is explicit connected redistribution. Of a specific interface. In other words, this is in loop back. So show down. We have created loop map, RIP loopback, and match interpret loopback 0. Then we distributed it into RIP. This is connected metric, and this is specific connected redistribution. Okay, when explicit connected redistribution of a specific interface is done into protocol, for example OSPF, and another protocol, for example EIGRP, is also being redistributed into in addition to connected, then the connected interface of our second redistribution will not automatically redistribute into OSPF. We have to add it into root map. The connected interface of our EIGRP must be manually accounted for in connected redistribution into OSPF. So I will explain this in our topology. This is connected redistribution concept. Okay, now let's configure this section. Now redistribute between RIP and OSPF on R3. Okay, let's start R3. Okay, now here I have RIP. I have this connect the specific interface of our loopback, and I have OSPF. And I have OSPF. I have also a specific connected with my PF for our loopback. It is connected to OSPF, and we have match interpret loopback. This is connected to OSPF. Okay, let's conquer RIP into OSPF first. I want to let's I open our file here. Okay, config T. The OSPF 1. And it says use an OSPF metric type that increases as the route propagates to the networking on RT. It means that we have to use type 1. It will propagate. It will increase our cost. If we propagate it to network, we have to use type 1. Okay, redistribute RIP. Metric type. Oops. One. Okay, now topology here. Where is that topology? That's snap. Go out with distribute RIP into OSPF. I have to see this network 1.39 on R5. Let's verify. If I see, I can see that network. Why? This is the same rule we have here. When explicitly connected distribution of a specific interface is done into protocol. Okay, yeah. On R3, I have a specific connected loopback into OSPF. Use OSPF. And another protocol, this is in our case RIP, is also being distributed in addition to connected. Okay, we have, let me check, we have loop back, we have specific connected, loop back into OSPF. This is our interface. We have redistribute connected loop back into OSPF, and we have redistributed RIP into OSPF. This is our RIP into OSPF. Then the connect interface of our RIP will not advertise. The connected interface of this RIP, this will not advertise. Right. I have to add this network into route map of this connected loopback. I have to add this network into our route map here. Add this in this route map. On this route map, I have to add match interface, this 1.39. This interface. Now if I go on type, now I see this route is advertised. This is our interface. I couldn't see that interface before. 35.5. This is all I can see here. See that route. Yeah. This is our 46. Okay, now let's redistribute it into OSPF. This is I have to redistribute OSPF into RIP. OSPF R3. What a RIP. Redistribute OSPF 1 Matic 1. I have to admit, okay, yeah, it is the same on our here. For RIP I have a specific connected interface. This will connected metric 1, this with map, the loop back, and I have this a specific connected interface into RIP. We loop back. This is our loop. This is a route map. Favorite route map, and also I have Redistribution of OSPF. Then the connected interface of this OSPF will not redistribute. I have to manually add these interfaces in this route map. This route map here. I have to add these interfaces into this route map. Okay, exit. Route map. RIP route map. Then match interface. One is one. Where is this? What is this one? 35. And match interface. This one. Going on R9. Short route. We have this network 135. So let me show. Five. On ping. I have to ping. It says non-wire RIP. If I do show IP RIP, we will see this within our RIP. This is our RIP. This is distributing via RIP. We have this in our RIP databases, and we don't have advertised bar because this is not happening. We don't have a distribution for that route in our current router. Okay, this is this part. Now let's go others. Continue others. Okay, confirm mutual distribution between OSPF and EIGRP on R4 and R6. Implement a redistribution plan that will allow the network to maintain full reachability in case of link failure between R4 and R6 interfaces on 1.46 and 146. This is this network. This network's here. And prevent loop in the network by modifying administrative distance whenever necessary and ensure full reachability between all these 14 protocols. Okay, if we do mutual redistribution on R4 and R6, the only routes that will cause loop are these networks. If I do mutual redistribution on R4 and R6, only these routes loop back 0 of switch 1, 21, and this interface VLAN will cause loop. Okay, before I do mutual redistribution, let me show that advertent distance of that route on our 4. Go to show IP route. To forward this on our 4. We see that route via EIGRP and distance is 170. On our 6 IP route, this is 170, and for this network short route, this is 170, and on 9. Alpha 6, this is 170 either. Okay, let me conquer the redistribution on our 4. Show down smart behavior. Okay, we have OSPF and specific connected interface for loopback, and we have EIGRP. We don't have specific connected interface. We have to create one for EIGRP. Well, let me distribute the EIGRP into OSPF first. This is new redistribute EIGRP into OSPF. EIGRP, I have two interfaces, one is this and this, 146 and 124. And I have 146. For 146 is for OSPF and 1.146 is for EIGRP. Okay, let's configure EIGRP into OSPF. I'll go into OSPF, config T, to OSPF 1. And this EIGRP is AS5. Okay, redistribute EIGRP AS5 subnet. Okay, the same will the same will apply here either. I have explicit candidate disposition. Okay, let me black it into OSPF. Okay, I have explicit connected with map. This is match loop back with map into OSPF. Then I have redistributed EIGRP into OSPF. Then the connected interface of EIGRP will not advertise. I have to add this connected interface into this route map. Okay, under this route map, I have to match connected interface of EIGRP. Which are 1.24 before the match interface. Go show interface brief. Okay, now match interface. This is 1.24. I have to add this into with map and match interface this 156. Okay, now let me create route map for EIGRP and advertise. I will say create route map. Let me say connected into EIGRP. Permit 10. I have to match first loop back. Match into loop back. Loop back 0. Okay, let me explain. Okay, now I want to distribute OSPF into EIGRP on our 4. I have a specific connected interface. This is our route map. Maps. Specific connected route map. This is distributing to EIGRP. This is distributing to EIGRP. Then I want to distribute OSPF into EIGRP on our 4. I will distribute OSPF into EIGRP. Then connected interface of OSPF. This is 1.46 will not advertise. I have to add this 1.56 into this route map. Okay, I have to add match interface. This is connected interface of OSPF into our route map. Then on the rotate EIGRP, on the topology, first address family. This is our address family. Then topology base. Okay, before I distribute, let me verify metric. Okay, which interface? Show interface. To show interface. It's 156. This interface is our metric. Okay. Redistribute. OSPF 1 and default metric is bandwidth or bandwidth. Where is our bandwidth? Oh, okay. This is our bandwidth delay this is delay in terms of microseconds. I have to specify 100 instead of 1000. Then reliability, two five five, and load. allow this one, and maximum unit is this one, MTU. Done. Okay, this was mutual redistribution on R4. Do showdown. Register EIGRP into OSPF and OSPF into EIGRP, and I added those interfaces that will not advertise for that rule. Okay, now let's do distribution on R6. What are we going to see? Let's see what we have here. Okay, we have EIGRP. We distribute specific route redistribution, and we have two OSPF processes. This rule will apply for two OSPF either. I have one specific for OSPF 1 and one specific connected for OSPF 2 and the IGRP. We have the IGRP. We have to be a little careful here, it's a little confusing. Okay, this is OSPF process 2 and OSPF process 1. This is the interface of OSPF process 2. These two are the interfaces of OSPF process 1. This is OSPF process 2, the OSPF process 1, and this is the IGRP. Okay. Let's redistribute OSPF into EIGRP first on R6. Okay, let me create route map first. Route map. Connected into EIGRP and permit 10. I have to match first in loopback 0. Okay. Okay, this is interface of OSPF process 2. These two are interfaces of OSPF process 1, and this is the IGRP. Okay, I do specific route map into IGRP, specific connector to map into IGRP. IGRP. I have to specific connected route map into IGRP, and I also want to redistribute OSPF process 1 and 2 into EIGRP. This is OSPF 1 and this is OSPF 2. Then the connected interface of this OSPF 1 and 2 will not advertise into EIGRP. I have to manually add this interface, connected interfaces of OSPF process 1 and OSPF process 2 into this route map. This should be 161. I have to add this into this route map. Match interface to show IP interface page. Match interface. One is 168. Another one 156. This to show RP OSPF interface. If the other one is this 56. Okay, I don't have to advertise this into our network because it will cause loop will, will between R3 and R6. Let me remove this one. 56, yeah. It's because fed back into R3. We only have to care about these two interfaces. And the reachable link file between this. Let me remove this from with map. Okay. With map. No match. Okay. These two interfaces are enough for our scenario. One is 1.46 and 1.68 into IGP. Okay, now I'll redistribute into IGP with IGP. Now let's go to IGP. Press 5. Administrative distance. Here's number. And topology base. Redistribute connected route map to connect it into IGRP and do show before then redistribute OSPF 1 and redistribute OSPF 2 and do show interface automatic OSPF. Let me check 1.46. Default metric is bandwidth. Delay is tens of microsecond. 255 is reliable. Load is 1 and M2 is this one. Okay, now let's redistribute the IGRP into OSPF. Config T, go to OSPF 1, redistribute EIGRP 5 subnet. Exit. To OSPF 2 and redistribute the EIGRP 5 subnet. Now let's check our root maps. Show on. Okay. It's not this. Block. Okay, we have a specific root map into OSPF. Let's be connected root map into our OSPF. Then I have this with EIGRP or into OSPF either. Then connected interface of this EIGRP will not add better. So I have to add this 1.156 into this root map of OSPF 1. Let's check. This is OSPF 1. I have to add this into this root map. This root map is redistributed into OSPF 1. And I have to add this interface into that. Matching type. This. Okay. Now this rule we apply here. We have a specific connected interface into OSPF 2. We have EIGRP into OSPF 2, and we have to add this interface into this root map. This is to show on. This is connected into OSPF 2. This is our root map. I have to add this interface into this root map either. Match interface and this. Show on. Okay. Okay, let's see. Yeah. So now, let's ensure reachability, and I have to payment this loop. Let's create it. This sort map. This is a okay. As I said before, I will have loop for these two interfaces. Interface RIP. For this loop back. Okay, on our 5. Let's test this. Okay, I have loop for this loop back of switch 1 and this interface. On our 5, if I do test root and I test this root, I have loop. If I okay, let's manage this. Okay, now we're going to go on our 4. I do sharp root this one, switch, switch one. This one. It says non via EIGRP. Then it says non via EIGRP. On our 4, on our 6. Okay, now 6 says it's now via OSPF. Next. It was EIGRP before I do redistributor. On 3, on our 4. This is the number EIGRP and our solution number OSPF. Okay, how loop is created, because let me explain what is happening here. Okay, if R6 redistribute, does it distribute that into OSPF? This is if this R6 redistribute EIGRP into OSPF first. EIGRP, this is external, this is 170, this is 170, and we distribute into OSPF. R6 OSPF distance is 110. Then then R4 will prefer this OSPF route over EIGRP. R6 will redistribute EIGRP into OSPF. Then R4 will prefer this OSPF because OSPF has lower administrative distance. This is 110. Then it will feed back that route into EIGRP and it will cause loop. R6 is redistributing this EIGRP into OSPF. Then R4 will prefer this OSPF. Then R4 then redistribute again, feed back that route into EIGRP and so on. This will cause the loop here. If I see this trace on R6, for this network, trace the 154 then 56, this is the IGRP, then this one, this come to SPF, then EIGRP, EIGRP OSPF, EIGRP OSPF. This is because loop. Okay, now this is off. Let's check on off. Okay, if R4 distribute EIGRP into SPF first, This is 170 admin distance, that will become 110. Then R6 will receive this route via OSPF, not EIGRP. 170. Then I should then feed back this into EIGRP. This 170 into EIGRP. This will cause loop. This is the same. This is all happening between EIGRP and OSPF. How can we solve this loop? Okay, if I see on R6, show output route. This R6 is seeing it by OSPF, and R4, oops, route 21, 21, 21 and 21. It's not, see that by via EIGRP. Okay, I have to force this R4 and R6 to see these two routes, this I have to force R4 and RC to force this route, these two routes via EIGRP. Okay, I can now OSPF at the distance of OSPF for this route. I have to OSPF admit distance is 110. I have to, and EIGRP is 170. Let's look at this. Oops. EIGRP has admit distance of 170. OSPF 110. I have to force these two routes to see these two routes as EIGRP. I have to change admission distance of OSPF 110 higher value or lower than, I have to more than 170, for example 200. Change the admission distance of these two routes in OSPF to 200. This will force R4 and R6 to prefer EIGRP routes over OSPF. Okay. Let's check change admin distance of these two routes on R4 and R6. Let me first create OSPF. I can use my distance. For example, I want to show if I can use prefix list on issue 666. I beat. Okay, I can't use prefix list here. I have to use standard access list. Okay, let me create standard access list. Config T. Standard access list. IP access list standard. Let's see, prevent loop. It's available. Okay, permit as one is this one. And this is this network. Permit asked. Permit what card my bit will be this one 0 0 0 0 dash 0 0 2 5 5. Okay, that's it. Show it on. I have to create this on R6. config T, this one, exit. Okay, now for on the OSPF, and I have to change administrative distance of those network. What distance command? This distance, let's say 200. It should be over 250. Over one. It should be over 170. 50. Our neighbor is 666 000 and standard access list. I have to do same on R6. On R6, I only have to change distance of OSPF process 1, not process 2. Total OSPF 1, distance 4444 000. I forgot it. 250. Prevent this. Okay, now let's see how R4 and R6 see that networks. Go show IP root. R4. Okay, I saw only EIGRP on R6. I see by EIGRP. Both are R6 and R4 see those network by EIGRP. And let's check the other one either. Show IP interface brief. This network. Show IP root. Now EIGRP and show IP root. Now my EIGRP. Now let's check other networks. On R5, I have to ping 21. Let me test root 21. 21. Okay, loop has gone. Okay, now at the end, I have to ensure full reachability between RIP, IGP domains. I have this TLC, and in 5 I do this. CLS. Then this. Then I have to ping. Okay, I have full reachability on R5. Let's check on R9. R9 is in RIP. This is our RIP. CLS this is this network. Ping interface. Okay, I have full reachability and no loop. The loop only was for this two network. Then I have changed those network address distance higher than OSP, better than OSPF. I have forced this network to force this I force this R4 and R6 router to choose these two rules by EIGRP. How? By lowering OSPF address distance lower than EIGRP. I set OSPF address distance for those routes to 200. 200 is lower than 170. This is whoops. I've created change administrative distance for these two routes. OSPF administrative distance to 200 on this router and OSPF administrative distance of 200 for these two routes for 21 and VLAN. Wait, 121. Then 200 is lower than 170. Then R4 and R6 choose 170. This is EIGRP. That the loop is gone. Okay, I hope you have enjoyed this video, and thank you for viewing.